Hi, my name is Malunza Richard Pimenta. I'm currently pursuing BTech Data Science from Ajinkya DY Patil University, Pune. Today I'll be talking about data mining. What is data mining? Data mining is a process of extracting and discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and database systems. Data mining is an interdisciplinary subfield of computer science statistics with an overall goal to extract information with intelligent methods from a data set and transform the information into a comprehensive structure for further use. Data mining is an analysis step of the knowledge discovery in database process or KDD. Aside from the raw analysis step, it also involves database and data management aspects, data pre-processing, model and inference consideration, complexity consideration, post-processing of discovery structure, visualization and online updating. So let's start with the first topic, data cleaning and preparation. Data cleaning and preparation is a vital part of data mining process. Raw data must be cleansed and formatted to be used in different analytic methods. Data cleaning and preparation includes different elements of data modeling, transformation, data migration, ETL, ELT, data integration, and aggregation. It is considered to be a necessary step for understanding the basic features and attributes of data to determine its best use. The business value of data cleaning and preparation is self evident. Without the first step, data is either meaningless to an organization or unreliable due to its quality. Companies must be able to trust the data, the result of its analytics, and the action created from those reasons and results. Second, tracking patterns. Tracking pattern is a fundamental data mining technique. It involves identifying and monitoring trends or patterns in data to make intelligent inference about business outcomes. Once an organization identifies a trend in sale data, for example, there is a basics for taking action to capitalize on that insight. If it's determined that a certain product is selling more than the other for particular demographic, an organization can use this knowledge to create similar products or service or simply better stock the original product for this demographic. Third, classification. Classification data mining technique involves analysis and various attributes associated with different type of data. Once organization identify the main characteristics of these data types, organization can categorize or classify related data. Fourth, association. Association is a data mining technique related to statistics. It indicates that certain data or event found in data are linked to other data or data driven events. It is similar to the notion of co-occurrence in machine learning, in which the likelihood of one data driven event is indicated by the presence of another. The statistic concept of correlation is similar to the notion of association. This means that the analysis of data shows that there is a relation between two data events, such as the fact that the purchase of hamburger is frequently accomplished by the French fries. Fifth, outlier detection. Outlier detection determines any anomalies in dataset. Once organizations find aberration in their data, it becomes easier to understand why these anomalies happen and prepare for any future occurrence to best achieve business objective. For instance, if there is a spike in the usage of transactional systems for credit cards at a certain time of day, organizations can capitalize on this information by figuring out why it's happening to optimize their sale during the rest of the day. 6. Clustering. Clustering is an analytical technique that relies on visualization approach to understanding data. Clustering mechanism uses graphics to show where the distribution of data is in relation to different type of metric. Clustering technique also use different colors to show the distribution of data. Graphic approach are ideal for clustering analytics. With graphics and clustering in particular, users can usually visualize how the data is distributed to identify trends that are relevant to the business objective. Eighth, prediction. Prediction is a very powerful aspect of data mining that represents one of four branches of analytics. Predictive analytics use patterns found in current or historical data to extend them into the future. Thus, it gives organization insight into what trends will happen next in the data. There are several different approaches to using predictive analytics. Some of the more advanced involve aspects of machine learning, artificial intelligence. However, predictive analytics doesn't necessarily depend on these techniques. It can be facilitated with more straightforward algorithms. Ninth, sequential patterns. This data mining technique focuses on uncovering a series of events that takes place in sequence. It's particularly useful for data mining transactional data. For instance, this technique can reveal what items of clothing customers are more likely to buy after an initial purchase of, say, a pair of shoes. 10th, decision trees. Decision trees are a specific type of predictive model that let organizations effectively mine data. Technically, a decision tree is a part of machine learning, but it is more popularly known as a white box machine learning technique because of its extremely straightforward nature. A decision tree enables users to clearly understand how the data inputs affect the outputs. When various decision tree models are combined, they create predictive analytics model known as a random forest. Complicated random forest models are considered black box machine learning techniques because it is not always easy to understand the output based on their input. In most cases, however, this basic form of modeling is more accurate than using decision tree on their own. 11th, statistical techniques. Statistical techniques are at the core most analytical involved in the data mining process. The different analytical models are based on statistical concepts which output numerical values that are acceptable to specific business objects. For instance, neural network use complex statistics based on different weights and measures to determine if a picture is a dog or a cat in image recognition systems. Statistic models represent one of two main branches of artificial intelligence. The model for some statistical techniques are statistic, while others involve machine learning get better with time. 12th, visualization. Data visualizations are another important element of data mining. They grant users insight in data based on sensory perception that people can see. Today's data visualization are dynamic, useful for streaming data in real life and visualization by different color that reveals different trends and patterns in data. Dashboards are a powerful way to use data visualization to uncover data mining insights. Organizations can base data dashboards on different metrics and use visualization to visualize highlights pattern in data instead of simply using numerical output of statistical models. 13. Neural network. A neural network is a specific type of machine learning model that is often used with AI and deep learning, named after the fact that they have a different layer which resembles the way neurons work in human brain. Neural networks are one of the most accurate machine learning models used today. 14. Data warehousing. Data warehousing is an important part of data mining process. Traditionally, data warehousing involves storing structured data in relational database management system so it could be analyzed for business intelligence reporting and basic dashboarding capabilities. Today, there are cloud data warehousing and data warehousing in semi-structured and unstructured data stores like Hadoop. While data warehousing were traditionally used for historical data, many modern approaches can provide an in-depth real-time analytics of data. 15. Long-term memory processing. Long-term memory processing refers to the ability of analyzing data over extended period of time. The historical data stored in data warehouses is useful for these purposes. When organization can perform analytics on an extended period of time, it is able to identify patterns that otherwise might be too subtle to identify. 16. Machine learning and artificial intelligence. Machine learning and artificial intelligence represent some of the most advanced development in data mining. Advanced form of machine learning like deep learning offers highly accurate prediction when of working with data at scale. They are useful for processing data in AI development like computer vision, speech recognition, and text analytics using natural language processing. These data mining techniques are good for determining values from semi-structured and unstructured data. So thank you for watching and I hope you liked the video.